now?
नहीं, मेरा computer बाकी है.
Okay, when's computer science then?
It's on Tuesday.
Oh, that's why you're attending today.
Yeah.
But what's the lectures like? Whatever you have not, I mean, the class that you have missed, no? Please watch those
Yes.
lectures.
Yes, sir.
How was chemistry?
It was fine.
That's fine. Anything unexpected in the question paper?
I don't remember.
You don't remember. Okay, how was MCQs and assertion, reason, these type of things? You did fine in that, or
Some MCQs were a bit confusing.
you fine? Hello, Gautam. How are you?
Hello, sir.
Hello, hi. This is
I
your
just
first.
joined today.
Yeah. This is your first class.
Yes,
So,
sir.
can you tell me what school do you attend?
Sir, I study in Bahrain, sir. New Millennium School.
New. Okay, fine. So you're the first student here from New Millennium School. Okay. How many chapters are done in your school?
Sir, we are also in coordination chemistry right now.
Okay, coordination chemistry. So nomenclature is done in your class, in your school?
Yes, sir. Nomenclature is done.
Okay, fine. So you can attempt these questions, or you're not very
Yeah, I
sure
can.
about?
No,
Yeah, sure.
this one is fine for me.
Okay.
So today is like the question class?
No. I start the classes generally with whatever I have taught in the previous class.
Okay, sir. Okay. I should send the answer through chat?
No. For this, you can send the answer through chat, right?
Okay.
And you can also save my number. So, for
Okay.
example, if I want some structures and so such things, then I will ask you to send on WhatsApp. Where are you from originally?
I'm from Kerala, sir.
Okay.
What about you, sir?
I'm from India, and basically I'm from Jharkhand in India. But most of my, like, from 9th standard, I'm in New Delhi. Then my bachelor's was done in New Delhi itself. My master was done in Bombay. But
All right, I see.
yeah, if I sent the answer. Just a second, guys. Let me see something. Fine.
So what is EN?
Krishna, last class, see your notes. You will see EN. Also, I advise Atif to look at EN and look at the category of ligand which it falls into, and then rethink about the coordination number of the complexes in which EN is the ligand. Krishna, let me know if you can find EN somewhere in your notes from last class.
Sir, it's not in the table which you gave.
So no, but we did something else also, right? See, that means it is not in monodentate, right? We also did
Yes, sir.
bidentate. Look into bidentate and or didentate ligand.
Okay, yes, I found it.
Got it? Now that is right, Atif. I think so. I have not looked at the other answer, but I think this is fine. Okay, so PT. First one, yeah, now it is correct. Second one, yeah, fine. And fifth, fourth one is, I think we changed the fourth one also. The fourth one is now correct. Fifth one is fine. Sixth one is fine. Yes, Atif, good work. What about others? Send the answers fast. Duna, were you present in the last lecture?
Yesterday?
Yesterday, yeah, right.
No, sir.
Oh, okay, fine. So Dona cannot answer. Krishna, I'm waiting. Okay, Krishna, I think you have sent the answer. Okay. You got the answer from Krishna. Also waiting for answer from Hamza and Hiba. No. Krishna, first one and the fourth one. Try to rethink about them.
Others are correct.
Others are fine. Okay, please look here. For En, what is En? En is ethylene diamine. It is what? It is ethylene diamine. Structure of ethylene diamine is we have carbon and carbon attached to each other, and then we have NH2 and NH2. Both of these nitrogens are capable of forming bonds to the central metal atom. That means there are two ligating atoms. Okay, that means there are two atoms which are forming bond with the metal, and that is why the denticity of En, that means the number of atoms which is coordinating with metal, is equal to how much? 2 for each En. That means if we have En2, then the number of coordinate bonds that will be formed will be equal to how much? It will be 4. So for the first one, the number of coordinate bonds that is being formed, that means the coordination number is equal to how much? 4 plus 2. This is going to give you 4. This is going to give you 2. So this will be equal to 6. Here it is easy. It is equal to 4. Here it will be again 6 because En3, that means 3 into 2, that is equal to 6. Here it is easy. It is 8, and here it also is. Here is also easy. It's 5. Okay. Please write this down. The answers. Now it is correct, Krishna.
So could you explain the first one again?
First one.
Hmm.
You understand this part? That the structure of ethylene diamine is something like this?
Yes.
Okay. Now, how many coordinate bond is it making?
2.
2. Okay. That means if I have one En, the number of coordinate bonds that I will be getting is 2. If I have 2 En, then I will be getting how many coordinate bonds?
4.
4. So I have what? I have 2 En, and that is giving me 4 coordinate bonds, and 2 chlorines, which is giving me 1 coordinate bond each. So 4 plus 2 is equal to 6. So the coordination number for this will be 6. Got it?
Yes, sir.
Right, next. In the last lecture, we did monodentate and di or bidentate ligands. Today, we are going to write about polydentate ligands. Please write ligands having more than 2 donor atoms. Ligands having more than 2 donor atoms present in the molecule is called polydentate ligands. Write these two down and then write this one also. Raise your hand once you're done. Is everyone done? Yes or no? Please tell me.
Yes.
Yes.
No suggestion.
Acha. Okay.
Done, sir.
Okay.
So what's the name for the last one?
The symbol for it, it is being used as EDTA. Okay. The full form for EDTA will be ethylene diamine tetraacetate ion. Ethylene diamine tetraacetate. Okay. Let me write that down. Ethylene diamine, two amines, tetraacetate. Tetra means 4, acetate are these ions 1, 2, 3, and 4. Okay, 4 negative is just for the charge, EDTA. Ethylene diamine tetraacetate. Right, next, denticity. Please write the number of coordinating or ligating groups present in a ligand. It's called denticity of the ligand. Okay, so for example, if I talk about the denticity of En, you will say that the density of En is equal to 2. Similarly, density of EDTA4, EDTA4 negative will be equal to how much? Tell me. Density of EDTA4 negative will be, so it is going to coordinate from the 2 nitrogens, that means the diamine and the tetraacetate. So it is total 6. Okay, so density of En is 2, density of EDTA4 is how much? It is equal to 6. Similarly, if you have di-N, what is di-N? It is diethylene and diamine also. Okay, so what is the density here? The density for di-En is equal to how much? 3, right? देखा ना आप लोगों ने? Wait, see this one? Di-En. So it is going to coordinate from this nitrogen, and this nitrogen. So it is equal to 3. So density gives the number of coordinating or ligating group that is present in a ligand. Right, next, chelation. Chelation is just another word for ring formation. So when you have a metal atom like this, and it is bonded to two different groups, and these groups belong to only one ligand, now you can see that there is a ring formed. Okay, so when you have a didentate or a polydentate ligand, and it uses two or more donor atoms, and it binds together and it forms a coordinate bond with the central metal atom, and while it is forming the coordinate bond with central metal atom, it is also forming a ring. In that case, we say that chelation has occurred. Okay, in that case, we say that chelation has occurred. Right, next. Just a second. Oh, कब से माइक मेरा ऑफ था? Sorry, guys. Listen. Was it off while I was writing the ligand that forms a ring is
Yeah,
called
sir.
Yes, sir.
तो बोलना चाहिए ना आप लोग को शांति. You understood this chelation and all till here?
Yeah.
I think you must have understood this. I mean the definition when a didentate or quadridentate ligand. So suppose you have a metal atom, and let's suppose we take the case of ethylene diamine. So I have two carbon atoms, which is one is bonded to NH2, another is also bonded to NH2. So both of these nitrogens are going to form coordinate bond, and it is going to form a ring. So I think this is kind of understandable. But what I was explaining here with the two structure was when you have a metal atom and you have some ligand. Okay, so both of these atoms are same, but in one of the case it is part of only one ligand. When it is part of only one ligand, it is forming a coordinate bond. It is also forming a ring. When here it is forming a coordinate bond, both of these atoms are independent. When you want to break this one bond, okay, in both the cases, the reformation of the bond in first case is quite easy because it will be near the metal atom. Why it will be near the metal atom? Because this ligand already has one bond that is present, and this atom, this green atom, is not going to go very far away from the metal atom. That is why the probability of reformation of bond is very high. And if reformation is done, that means whatever energy you have spent for the breaking of that bond, it is lost. You need to spend that energy once again. So breaking of this bond is quite difficult in comparison to breaking a bond with ligand and metal, which is independent. And that is why we say that the chelating ligands, they form stable complexes. Okay, so right, chelating ligands form stable complexes. All of you understood this now? Why chelating ligands, they form stable complexes?
Yes, sir.
All of you wrote this? Yes or no? Please tell me.
Yes, sir.
Yes.
Yes, sir.
All right, next. Ambidentate ligands. This thing. This is very similar to the ambidentate nucleophile that you have learned in halogen. Please write the monodentate ligands. Which can coordinate with central metal atom or ion through more than one site. For example, you have NO2. So NO2 can coordinate with either nitrogen like this. In this case, it is known as nitro. It can also coordinate with the oxygen atom like this. In this case, it is known as nitrito. Or it is also known as nitrito dash O. Here it is also known as nitrito dash N. KNO2 and AgNO2 type का structure है यहाँ पे ना, if you remember it from the haloalkane halorine. Similarly, you have CN and NC. You have metal atom. If it is bonded with CN, it is cyanide. NC, it is isocyanide. Metal atom bonded with SCN. This is thio. Cyanato. And if the metal atom is bonded with NCS, this is iso thio cyanato. All of you done? Yes or no? Please tell me.
No, sir. One second.
Okay, right.
Yes, sir.
Anyone still writing? No. Okay. Right, next. Homoleptic and heteroleptic complexes. Please write with me. Complexes with only one type of ligand is called complexes with only one type of ligand is called homoleptic complexes. and complexes with more than one type of ligand is called heteroleptic complexes. Right, next, rules for naming coordination compounds. Rules for naming coordination compounds. Right, the first very basic and simple rule. Ionic compounds okay, wait a second. Right, in ionic compounds. Right, in ionic compounds. The cation is named first and then the anion. Okay, for example, we have sodium chloride. So how do we write the name? NaCl, this is the formula. The name is sodium chloride. So this will be Na plus and Cl negative. Okay, so we write the name of cation first and then we write the name of an ion. And similar will be the case for coordination complexes also. Okay, so the coordination complexes, it can be cationic or anionic and they will have counter ion. So if the counter ion is cation, then that counter ion will be named first. And if the counter ion is anion, then the coordination sphere will be named first. Okay, so right, next, naming of the coordination entity. Okay, for example, आपके पास okay. All of you wrote this first point, yes or no, please tell me.
Yes, sir.
Okay, let me give you an example here. We had some structures, right? Okay, so here you can see what is the cation here in this structure. The counter ion is the cation, right? K4 is the cation, right? So you'll just write potassium, okay, for the counter ion, and then we need to name this particular coordination entity. Here, if you see in the chloride, this will be chloride as it is, no change. Okay, we need to just understand how to name this particular coordination entity or the coordination sphere. Okay, so our main problem is the naming of coordination entity. Right, the next second part. Naming of coordination entity. Right, in the coordination entity we have two things. Coordination entity, it consists of the central metal atom and the ligand. So we name the ligand first, please write. The ligands are named first. The ligand are named first, then the central metal atom. Okay, And now right next, naming of ligands. Okay. In the naming of ligands, you have to understand that ligands are of three categories. You have anionic ligands, you have neutral ligands, and you also have cationic ligands. And the naming convention for all of these three are different. For example, if we are going to name an anionic ligand, then the name is going to end with O. If we are going to name a cationic ligand, then it is going to end up with IUM. Neutral ligands, these are named as it is only. Okay, so right, in the naming of ligands, the name of anionic ligands, the name of anionic ligand ends with O. The name of cationic ligand ends with IUM. The neutral ligands are named as it is. Please write this down. Also, just see here, this whole thing is oxalator. Okay, this whole thing is oxalator. Let me know once you are done till thiocyanate, and then I will scroll down. Done, everyone?
Done, sir.
Please write. Yes. Everyone done? Yes or no? Hmm? Still writing? Right, right.
Done, sir.
Anyone still writing?
Yes, sir.
Okay, okay, okay. Those who are done, they can write this. You don't have to sit and memorize all of these names, okay? We'll practice questions and then you're going to pick it up till the end of this like this complete chapter. I mean, if you do remember all of them, then it is well and good. But again, I will not suggest you to sit and then memorize this whole thing. It would be nice if you just have a look at it uh, on a daily basis. Okay, just read it out loud and then just try to remember it once. If you don't remember it, that's fine. Don't repeat the process once again. Okay, just read it once and try to remember something. Then the next day, read it once, try to remember something. Rather, it will be even better if you try to do a few questions. Raise your hand once you're done. Is there anyone who is still writing? Atif, Heba, Kinsa, anyone still writing?
No, sir.
Write a note. Some neutral ligands are named a bit differently from their general names. Okay, for example, water, it is named as aqua. NH3, whose name is amine with a single M, it is named as amine with a double M. NO, it is named as nitrosyl. Carbon monoxide is named as carbonyl. CS is named as thiocarbonyl. Okay. Write these notes down.